you guys always. Okay, let's take some notes. I, today, am going to use some pens, colors, and a couple highlighters. So you might want to have something like that. Please have your name on there. You can see my name is on there. It's really important to put your name on things. Okay. Today we are making sure we all know how to multiply and divide fractions. Will we be able to use calculators in the future? Yes, we will. But I always like to start the year just saying, hey, you learned this probably in 5th grade. That's when my daughter learned it. So in 5th grade, you were doing this stuff. We want to make sure that we remember how to do it so that we can when asked. But it's always just good skills to remember. So our final answer should be reduced, simplified as much as possible. So that's important. We want to make sure that we reduce our fractions. Eventually, I'll show you how to use the calculator. All right. When possible, I am going to model things so that you understand that these are not just weird rules we made up. This is how it happens, okay? Where does it come from? Why do we do that? Okay, so when possible, I'm always going to model it. So multiplication, we learned, I already talked about this a few minutes ago. We learned that multiplication means 5 groups of 9 in this case, in each group, or maybe we had 5 rows, 1, 2, 3, 4, 5 rows with 9 objects in each row, or 9 units in each row, whatever it is. I'm not going to try to do 9, I'm just going to pretend. There we go, maybe that was 9, I don't know. You get the idea, right? So if we have 9 unit cubes in each row, how many unit cubes would we have in all? 90. 5 times 9 is 45. 9 times 5 is 45. Okay, so multiplication can always be modeled using the box method, is what I call it, or an area model. That's what this is. It's an area model. Multiplication is area. And so we can actually do the same thing when we are multiplying fractions, okay? And again, some teachers teach it this way, like you learn it this way. We're not going to do it this way always, but I'm just going to remind you that this was a way. We're going to do the same thing. We have multiplication here, except we're multiplying fractions. And so we're going to do the same thing. I have a product of 2 things, except now my first thing here is 7/8. Is that more than 1 or less than 1 whole? It's less than 1 whole. 8/8 would be 1 whole. Okay, this is less than 1. So what I'm going to do is I'm going to go ahead and figure out how to show, how do we represent 7 out of 8 pieces? Okay, so we need 8, right? Okay, so I'm going to separate this into 8s. So I'm just going to start when I have an even number. I'm going to cut it in half, and then cut those in half again. So now I have 4 pieces. How do I get to 8? Cut those in half again, yes. So this way, everything is really nice and neat. That's pretty fancy to do it that way. If you like to bake brownies, like we do a lot of baking in our house, and my kids all know if you want to cut your pan of brownies, you start in the middle, and then you divide that, each of those in halves, and then you get perfect cut brownies every time.
That's what Mom taught me.
Yeah, you always start in the middle, and then divide those in the middle. Okay, so we want to model then, we want 7 parts out of 8 total pieces, so 7 out of 8. I'm going to take my highlighter, and I'm going to highlight those 7 out of 8 parts. So there's 1, 2, 3, 4, 5, 6, 7, 8. 7 out of 8 pieces shaded. And then on the other side, we want 4/5. So again, how many pieces do I have to divide my this top edge into 5 pieces. 5 odd is a little bit harder. We just have to be pretty. 1, 2, 3. See, I started too big. All right, we're going to pretend that those are all the same. We're totally pretending there. And again, I need to shade how many of those? 4. So I was doing vertical columns here. So 1, 2, 3, and there's 4 columns out of 5 columns shaded. So now, how many pieces are overlapping? Where is the orange? Because pink and red make orange. Or sorry, yellow and red make orange. How many of those orange pieces are there?
32.
Not quite. So don't count the bottom here because those are just pink. 28. Yes, there's 1, 2, 3, 4 along the top, and 1, 2, 3, 4, 5, 6, 7 along the side. And so 4 times 7 is 28. 28 overlapping little babies. Okay? Out of how many total pieces are there in my rectangle there? 40. Yeah, there are 8 rows and there are 5 total columns, so that is a total of 40 little baby pieces. Okay, how many of you want to draw this stuff out every single time you multiply fractions? I don't think so. We never do that, right? So how do we, what's the shortcut? How do we get 28 out of 40?
Cross multiplication.
Cross multiplication is an interesting way to say that. So if we're cross multiplying, do we do 7 times 5?
Yeah.
Where's 35?
Numerator times numerator.
It's numerator times numerator. It's not cross multiplication. It is straight across. Oh, well, see, and I wouldn't ever call it cross multiplying. So, in order to multiply fractions, all you do is go straight across. So easy. Don't make it complicated, okay? It's okay, don't apologize. I hear it a lot. So, but straight across. So easy. So we're going to make a little note here. All we have to do is go straight across. And highlight that, and maybe, you know, that's all we got to do, is go straight across. Okay, are we done?
No.
No, what do we need to do?
Reduce.
Got to reduce, simplify, reduce or simplify. Both of these numbers can be divided by 4. Good. You don't have to write this down, but I like to in notes. They both are divisible by 4, but maybe I didn't know that. And maybe I just saw that they're both even numbers, so I want to just divide both of them by 2. 28 divided by 2 is 14. 40 divided by 2 is 20. Am I done? No, because as you said previously, it was divisible by 4, so I'm just going to do it again, and that's okay. If you didn't know they were both divisible by 4, just keep going until you can't reduce anymore. And 14 divided by 2 is 7, and 20 divided by 2 is 10, and we are finally done. Okay? Okay, so creating fractions and multiplying can be done with the area model just as well. Let's look at C and D. Again, we're multiplying. How do we multiply? Straight across. Thank you. 1 times 10 is 10. 8 times 9 is. They are divisible by 2. Good. Ooh, okay. 10 divided by 2. 5. 72 divided by 2. 36. Can they reduce any more? No, that's it. 5 is what kind of number? Prime. Yeah, it is prime. What does that mean when it's prime?
Can't be reduced anymore as you can't reduce it.
So prime technically means that it's only divisible by itself and 1. Okay? Not 0. Nothing's divisible by 0. So just 5 or 1. And so that is prime. The only way we could reduce this is if 30, if this was like 35, if this was a multiple of 5. If we had 35 or 40 or 20, okay? But I like to just recall vocabulary. All right, again, here was times. This is also times when we use the dot. Okay, we have to know both ways. Also means multiply. How do we multiply fractions? Straight across. 3 times 1 is 3. 8 times 2 is 16. Does it reduce? No. Questions so far? Easy or hard?
Easy.
Good. Okay. Did you learn how to model fractions multiplication this way?
No.
You probably did it a couple of times, but
I did never use that model.
yeah. So this model is actually in Delta Math, and it's pretty cool. Like, to do it. I like it. It's fun. Maybe one day if I'm bored, we'll do it. All right. So division. Division. When we divide things, if I say like, I have, I don't know, $132, $132, and I have 4 friends. I'm gonna give them some money because evidently that's the only way I can make friends. So, when we do division, I'd be answering the question: how much money does each friend get? All right, I have $132, I have 4 friends, and I would just like deal out the dollars, right? Right? And then how much money would each friend get? So it's how much money they get, this little bit. How much does one little person get? When we are thinking about this, I'm saying, hey, I have half of something, okay? And I want to know if I take a half and split it into 4 equal parts. If I split the 1/2 into 4 equal parts, how big is each part? How big is each little bit? How big is each part? And that's the question that we're asking when we are doing division by equal groups. And so again, I can model this pretty easily. So I'm going to start with a half. And is a half more than 1 or less than 1? It's less than 1. And I need to model that. So 1 is the whole thing, so we're going to split it into 2 parts. And how many parts should I shade? 1/2. Good. I just want 1 out of those 2 parts. So there I go. I'm going to shade that 1 part right there. Okay. Now I want to take that 1/2 and I'm going to divide it into 4 equal pieces. All right, well, I can split that up. I can cut it that way. That's 2 pieces, and then I can cut each of those in half again. So now I split it into 4 equal parts. How big is each part? Well, here's the 1 part. That is each piece. What size is that piece? Well, it's 1 piece, right? There's only 1 there. Out of how many total pieces? 8. Remember, this whole thing started as 1 whole unit. We cut it up. Now there's 8 pieces. 8 little babies total, okay? So how do we go from this kind of division and get an answer of 1/8? Like, it's not, like, this is 4/1, let's say. It's not straight across anymore. It's not 1 times 4. That would give me 4. You do. You flip the fraction. Oh, yeah, so division, we have to keep, change, flip is probably what you've heard before. You've heard that? Or multiply by the reciprocal, which is the more mathy way to say it, okay? So that second fraction we flip it upside down and change the problem to multiplying. So this is how the math works. Well, now we get to multiply straight across. 1 times 1 is 1, and 2 times 4 gives me the 8, okay? If we did this enough, modeling with this picture, you'd eventually see that, oh, I need, instead of dividing, it's really just multiplying that 4 times the 2. But we like to say keep, change, flip because it's just easier. Okay, so when I look at a division problem with fractions, we keep the first fraction. We change division into multiplication, and we flip the second fraction. Keep, change, flip. And so we have 1/4 times 7/9. Keep, change the sign, flip the fraction. Rewrite. Yeah, please silence your phone. That would be most agreeable. Thank you. Feel free, if you have your phone, to silence it as well. Good. You should. Good for you. Nice. Okay. Now that we're multiplying, how do we do it?
1 times 7.
Straight across. 1 times 7 is 7. 4 times 9. 36. Very good. Does this reduce? No. Good. Final answer. Are you customary? Do you use equal signs like I do?
Yep.
Good. I like that. All right. We have a division. Do we divide fractions? No. What do we do? Keep, change, flip. Write it down. That's what notes are for. KCF, always confused with KFC. Dan, they got good chicken. All right. I've never been to Popeyes. Florida Churches? Anybody been to Church's Chicken? Well, we had. What do we have? There was another one. Chester's Chicken. I've never had. Have I had Chester? I don't think I have.
I love Zach. Actually, I like the best.
Okay. All right. So keep, change, flip. We keep the first fraction 4/7. We change to multiply. We flip the second fraction, and now we can multiply straight across. 4 times 3 is 12. 7 times 2 is 14. Look at that group participation. Rad. What can they both divide by? 2. And 12 divided by 2 is 6. And 14 divided by 2 is 7. Oh, okay. All right.
Yeah, she's very funny.
All right. So, once again, keep, change, flip, because we do not divide fractions. We are going to keep the 4/3. We're going to change to multiplication, and we're going to flip the second fraction. And I love how some of you are already done and some of you are ahead of me. That is how you should do your notes. Don't wait for me. If you can go ahead, that is the best way. You're using your own brain and just making sure your answer matches when you're done. We're going to multiply straight across. 4 times 3 is 12, and 3 times 5 is 15. Am I done? No. Can we reduce? Divide by 3. Okay. Don't forget to divide if you can. 12 divided by 3 is 4, and 15 divided by 3 is 5. Wait a minute. I see those numbers over here.
Whoa.
What? If there's a 3 on top and a 3 on bottom, can they just reduce? Right? Okay. If you did see that and happen to notice, they do, in fact, if you have a 3 on top and a 3 on bottom, they do just reduce. 3 divided by 3 is 1. It goes away. We don't care about that. So we're just left with 4/5. So there are shortcuts, but I'm always going to do the straightforward way that works every time so we don't confuse ourselves. Okay? Do you have any questions for me? How do you multiply fractions? Straight across. How do you divide fractions? Excellent. Good job. All right. You guys have a Delta Math assignment. So grab those Chromebooks.